Welcome to 3.3. In this section, we will be taking a look at the domain and range of graphs. In slide 2, we go over the overall understanding of what a function is and what it relates to as far as the x and y values that are within that function. So, a function is a relation in which, for each value, the first component of the ordered pairs, there is exactly one value of the second component. So for every one x value, there is a y value. So your x values, they do not repeat. They will only occur once, and they will always come out with a secondary y that is once. So for every x value, there is only one y value that corresponds to it. Y values can be repeated though, okay? So as long as there is one x, you can have one x with one y, or you can have one x with multiple y's, but you cannot have multiple x's within your function. Let's take a look at slide 3. In slide 3, this goes over the understanding of what our points look like within our ordered pairs, what our dependent, independent variables are, and how they relate to domain and range. So to first start off, our domain and range. Our domain are always our x values. Our range are always our y values. Now, this is what we were kind of saying before about independent and dependent variables. Our independent variables are the x. In that case, anytime that we plug in an x value, it is a dependent variable. The y is dependent on the x value, meaning we cannot solve the equation and determine y until x has been plugged in. We begin to go over in slide 4 the different types of notations. Now, as we are taking a look at set notation, interval notations, and whether it's open, closed, or half open, half closed. So a graph has been given to kind of have a better understanding of what is generally occurring. So in our set notation, you can see x such that a is less than x, which is less than b. The most important thing to realize is that anytime we are working with set notation, we will be working it with inequalities, meaning we will be working with our less than and greater than sign, or less than or equal to, or greater than or equal to signs. Our interval notation mainly works in the same way as a set notation, where it is saying that certain numbers are going to be included or not included, but they use either open parentheses, closed parentheses, or an open bracket, closed bracket. Based off whether or not these are parentheses or brackets, or less than, greater than, less than or equal to, greater than or equal to signs, you can determine their type. Anytime that you deal with parentheses or less than or greater than signs, they will be open. And anytime that you deal with a bracket or a less than or equal to, greater than or equal to, they will be closed. There are times in which some of the interval notations or set notations will be half open, half closed. And what that refers to is determining whether it will include the value at which it's stopping or whether it will not include it. Now, that is generally occurring for bounded intervals. When we're taking a look at unbounded means it will continue to extend in a certain direction. Meaning, if we take a look at our bounded or unbounded examples, notice we are going from A to positive infinity. This would be open because it is a parentheses and it leads to the right-hand side and it continues to go to that right-hand side. Now that can occur in either direction, opening towards the right-hand side, like in the first example, or in the second example where it's extending that parentheses to the left-hand side. Now, what determines open and close for unbounded is not the fact that it continues to extend or it gets closed off. What it means by open and closed is whether or not you are using a parentheses or whether you are using a bracket. Notice in the case for examples 1 and 2, they are open because parentheses are being used for the first and second example. For examples 3 and 4, notice they are closed because they both have brackets. The first example has a bracket opening up towards the right side, and example 4 has a bracket that will open and continue to move towards that left side. Notice it does not matter as far as it continuing to extend to the right or to the left. It will always be closed because of the bracket that is there. When we speak of all real numbers, which is example 5, because we are going from negative infinity to a positive infinity, it will be open because there's an arrow going in both directions, and because we are working with parentheses in this case. Let's go ahead and take a look at slide 6. So we have our types of notations. Another way of describing our notations, yes, we have described our interval notation, which is dealing with parentheses and brackets. We have spoken of our set notation, where we are writing whatever the variable is that we are in reference to. So this would be x such that x, now we are using less than or equal to, greater than or equal to, less than or greater than signs in order to describe what numbers are being evaluated. And we would close it off with our set notation. Another method in which this can be used is in graphs. In our graphs, we use open and closed circles in order to determine whether it is including or not including our number. So keep in mind, a closed circle will include the number. An open circle does not include the number. So let's take a look at our first and second example. Our first example is a closed type. Notice our circle is enclosed, meaning we will include the A within that graph. Let's go ahead and take a look at example 2. In this case, we have parentheses A, comma, to positive infinity. In this case, we are not including the A, which is the reason why it is an open circle on our graph. And because we have a parentheses there by the A, it would be described as an open parentheses or an open type. As we go to our third example, we are going from negative infinity to positive A, and we have a bracket around it. In this case, we are including the A, and it is opening to the left-hand side. Now the type would be closed because of the fact that it is using a bracket, and it is including the number itself. Within our graph, you can see that this A is bubbled in. which will include it. Last example. In example 4, we have it going from negative infinity to positive a. And in that case, we are going ahead and we are going to not include the a, which means we will have an open circle for the graph. The type would be open because of the parentheses, and the set notation would be x, such that x would be less than a. Let's go ahead and take a look at slide 7. In slide 7, we begin to speak again of our upper-lower bounds and whether it is bounded. This is extremely important because it will give us an understanding of whether we are going to include such a number or not include numbers. These are the same ways that we were describing the graphs in the previous section. Now consider, remember, we are only taking a look at what is going up or what is going down. We are not paying attention to the middle. As long as it continues to exceed upwards, it is unbounded on the top. As long as it continues to go down, it is unbounded in the bottom. The only time that we would be bounded would be in our second example. Notice we have a stop at the bottom. That would be bounded below. And it continues to go up, which would be unbounded above. In our third example, we are bounded above. Notice it does not exceed that area, but we continue to go down, which means it is unbounded below. Our last example would be if it is bounded above and below, meaning it stays within a specific range and does not move from that range. In slide 8, we are going ahead and we are taking a look at set builder notation. Now, set builder notation, we have gotten to a point where we have seen it before, but the most important thing is understanding what it is speaking of when we see either a graph and having to write it in set builder notation, or writing it or seeing a set builder notation and creating a graph from it. Let's go ahead and take a look at various examples. We're going to begin with our first graph. And in that first graph, we are going to have a line that goes from negative infinity to positive infinity. We would write this as x such that x is equal to all real numbers. And in this case, we know that it would be unbounded because notice it continues to exceed upwards as well as downward. So this is unbounded. Another scenario would be if we had another graph Now, in this case, if we had a ray or a solid dot at one point exceeding to positive infinity towards the right-hand side, we would go ahead and describe this as x such that x is greater than or equal, and we're going to provide this with a random numeric value. We're going to call this -2. Now, how do we know that we are going from as x such that x is greater than or equal to -2? Notice we are using the sign of a greater than or equal to sign because it is a closed circle. It is a number that is exceeding towards the top and to the right-hand side. In this case, we would describe this as unbounded above and bounded below. Our third graph would be if we went ahead, started in one place, and terminated at another. In this case, the set notation would be x such that. Now we are going to take a look at the values that we have. In this case, we would be going from -2, as we stated before, is less than or equal to x, which is less than or equal to a +2. We would close off our set notation, and in this case, we would describe this as bounded or bounded above and below. Let's go ahead and take a look at slide 9. In slide 9, we begin to describe the differences between parentheses and brackets. Now, within interval notation, a parentheses means that if it's going towards an infinity or negative infinity, is that it will continue to go in that direction. Now, if a parentheses is next to a specific number, that means we are going up to the number, but we are not including that number. So, how do we write our interval notation? It will always be the smaller number that gets written down first, and then the larger number gets written on the right-hand side. This will occur at all times. Now, if interval notation, we are needing to use a bracket, that means the same thing as us using a, let's say, less than or equal to or greater than or equal to sign. This means that we are including the number that is being described within that interval notation. Once again, the same thing would occur. We would go ahead and write it down from the smaller number, comma, bigger number, and depending on how we use those brackets and parentheses. Let's go ahead and take a look at slide 10. So in slide 10, it says, identify the domain and range of the function below. First thing, let's start off with our domain. Our domain, in this case, can be written in one of two ways: interval notation or set notation. So we are going to begin with interval notation. Our interval notation, in this case, because we are being given specific numbers, would be an interval notation bracket 2 in union with bracket 4 in union with bracket 6 in union with bracket 8. The reason why we are using brackets is because we are including that number that is there. We use the union between these different brackets to describe how it is only the 2 and the 4 and the 6 and the 8 that are being included. This is extremely different than if someone was to write from 2 to 8 in this method. Why? Because from 2 to 8, as we see on that right-hand side, would include all the numbers in between it. That would be 2.5, 3, 3.5, 4.39, whatever those values are. But when we only use brackets and a specific number, that means there are gaps in between them. Let's go ahead and write this also in set notation. In set notation, we would first begin with x such that x is equal to 2, 4, 6, and 8. Notice in set builder notation, we are using commas to separate each one of them because we are stating that the values of x can only be a number 2, a number 4, a number 6, and a number 8. Notice we are not putting ourselves in a range of numbers. They are just those numbers specifically. Let's go ahead and take a look at our range. In our range, once again, we can write this in interval notation and set notation. Interval notations, once again, we are starting off with the individual numbers and we are placing them in between unions. So 7 within brackets in union 2, 11 in union with 15, in union with 19. Set notation. Remember, now that we are looking at the range and we are not looking at the domain, remember the domain is always our x, the range is always in reference to our y. So we would write this as y such that y is equal to 7, 11, 15, and 19. Once we finish that off, we go ahead and write our set notation on the back end. Let's go ahead and take a look at slide 11. Slide 11 goes ahead to describe how we go ahead and describe a range of numbers. So when we are writing the domain, we are including all of the x values from left to right, or from least to greatest. And the same thing would occur from the range. Now the range would be a little bit different because now we're looking at the y values, but we are starting with the lowest and we are going up to the top. So we are going from the down position to the upper position. But once again, we can go ahead and describe it the same way as from least to greatest. So our smaller number will always go on the left-hand side. Our larger number will always go on the right-hand side. Let's go ahead and take a look at slide 12. So in slide 12, we have two graphs that are being given to us. In these two graphs, we have various scenarios that are going on. So we're first going to begin with understanding and making it clear that our domain is equal to our x value and our range is equal to our y value. So let's start off with our domain. In interval notation, because we have a solid line that moves from left to right within that line, we can include and just do a parentheses from negative infinity to positive infinity and close it with another parentheses. Keep in mind the parentheses occurs because we are working with infinity. Now, in set builder notation, we would go ahead and write this as x such that x is equal to all real numbers. This occurs because notice the line continues to move to the left-hand side and it continues to move to the right-hand side. That would be one way of writing it. You can also write it as x such that negative infinity is less than x, which is less than positive infinity. Both of these methods would be perfectly fine to describe what is going on within that graph. Let's go ahead and take a look at range. In our range, once again, we'll start off with interval notation. In this case, we're going from the lowest spot on our graph, which would be at the 0 mark, and we are increasing to positive infinity. So we would go ahead in interval notation, use a bracket on the 0, and it is going to positive infinity. Our set notation would be written as y such that y is greater than or equal to 0. We close off our set notation with that fancy parentheses and continue on. What I would suggest, try to work on this one on your own and try to complete it. So let's go over this problem together. We'll start off with the domain. Our domain in interval notation would be from -2 to +2. We would have brackets on both sides because the line is going through the -2 and it is going through the +2. In set notation, this would be written as x such that -2 is less than or equal to x, which is less than or equal to a +2. We close it off with our set notation, and we are all set. Our range in interval notation, keep in mind we go from least to greatest. Least would be at the -4, greatest would be at the 4. In this case, we would go and have brackets from -4 to +4 and close off our brackets. Our set notation would be y such that y well, in this case, y such that -4 is less than or equal to y, which is less than or equal to a +4. Let's go ahead and take a look at slide 13. In slide 13, we go ahead, take a look at the domain. Our interval notation for this graph would be from -infinity to +infinity. Our set notation would be x such that x is equal to all real numbers. Our range in interval notation would be from -infinity to +infinity. Our set notation would be y such that y is equal to all real numbers. In slide 14, in slide 13, in our second example, we can see that here that we do not have a line. All we have here are individual points that we have to take a look at. The first thing to do would be to go ahead and identify all of these points. So this would be -2, 2. We can actually go ahead and write this in a clearer area. -2, 2. We have 3, 2. We have 3, -2. And we have -5, -2. These are extremely important because it gives us an idea of what numbers we are specifically going to hit, since there is no line that connects all of them. We begin off with our domain. In interval notation, we would set this as our x values being -5 in union with -2 in union with 3. Now keep in mind, 3 is written down twice because we have 0.32 and we have 3, -2, but we are only looking at the x values. So since 3 is being written down twice, we only have to write it down once. If we were writing this in set notation, we would write this as x such that x is equal to -5, -2, and 3. On the range of this problem, interval notation would be written as -2 with a bracket around it in union with +2 with a bracket around it. Keep in mind, both or all 4 of our points have either a -2 or a +2, which means we only have to put down 2 numbers. In set builder notation, we would go ahead and write this as y such that y is equal to -2 and 2. In slide 14, they are asking for the domain and the range of each relation, and they are asking for us to write it in set and interval notation for each. So the true question ends up being, is it a function or not? So let's begin with our first example. Our domain for this problem in interval notation would be from -infinity to +infinity, and set notation would be from x such that x is equal to all real numbers. Our range in interval notation would go from -infinity to +infinity, and our set notation would be y such that y is equal to all real numbers. Now, this is mainly able to be done because as we take a look at the domain and we are looking left to right, notice our domain extends from -infinity to +infinity, and our range goes from -infinity to +infinity as well. Let's take a look at the true question, which is this a function or not? In this case, yes, it is a function. This can be determined through one of a couple ways. we can check if there is a one-to-one relationship between our x and y values, or we can also run a vertical line test to also determine whether this is a function or not. So in this case, yes, it is a function. Let's take a look at our second example. In our second example, once again, we are looking at the domain in interval notation. Keep in mind, we are looking from left to right. Because it goes from negative infinity to positive infinity, that's exactly what our interval notation would look like, comma, negative infinity to positive infinity. Our set notation would go as x such that x is equal to all real numbers. Our range from this problem, keep in mind, we have a lowest point for that graph, which would be at a -6, and it continues to increase, which means our interval notation would be bracket -6, because we are including the -6, up to a positive infinity, which would have a parentheses. Our set notation would be y such that y is greater than or equal to -6. We go ahead and determine whether or not this is a function, and in this case, yes, it is a function. Slide 15, we have a very similar problem to slide 14. Once again, we are looking for the domain and the range in interval and set notation for each, and to determine whether or not it is a function. Let's begin with our first problem. Our domain in interval notation, keep in mind we are looking from the furthest left to the furthest right. In this case, we are starting at the 1, and we are going to a positive infinity. So we would have a bracket, -1 to positive infinity, and our set notation would be x such that x is greater than or equal to 1. I just realized that in our interval notation, we put a -1. This should be a +1. Let's go ahead and take a look at the range. In the case of the range, we are going from negative infinity to positive infinity. So we go ahead in interval notation. This would be described as negative infinity to positive infinity with parentheses around each one. In set notation, we would have y such that y is equal to all real numbers. When asked if this is a function or not, this would not be a function, because notice, as we insert one x value, right, as we draw our vertical line test, we are coming up with 2 y values. This is not a function. In our second example, we go ahead, take a look at the domain in interval notation. As we are taking a look at the x, Keep in mind it is extending towards the negative infinity and the positive infinity, which means parentheses negative infinity to positive infinity. And our set notation would be x such that x is equal to all real numbers. In the case for our range, keep in mind this is extending down towards negative infinity and it continues to move up towards positive infinity. So we would go ahead and write this from negative infinity to positive infinity. Our set notation would be y such that y is equal to all real numbers. When it comes down to the actual determination of is this a function or not, keep in mind, as we run our vertical line test, notice it is hitting at multiple spots, which means this is not a function. In slide 16, we want to go ahead and state if the graph is a function, then state the domain and range in set notation and interval notation. So when we are going ahead and starting off with our graph on the left-hand side, we first need to determine what points are being described. So we first begin with from highest to lowest, or we can start from furthest left to right. Let's start off with highest to lowest, which in this case would be negative 2, 5. We have 1, 3. We have 4, 0. We have 1, negative 2. And we have negative 3, negative 4. Now, as we start looking at the domain, the domain for this problem in interval notation, keep in mind because they are specific points, we have to put them individually within their certain brackets or parentheses. In this case, we would have brackets, and it would go as negative 3 in union with negative 2 in union with 1. Now keep in mind 1 is there twice, which means we only have to write it down once. And our final number would be 4. In set notation, we would write this as x such that x is equal to negative 3, negative 2, 1, and 4. As we go ahead and write down the range in interval notation, once again, we go ahead from the lowest to the highest. So this would be from negative 4 in union with negative 2 in union with 0 in union with 3 in union with 5. Our set notation would be y such that y is equal to -4, -2, 0, 3, and 5. When asked if this would be a function or not, in this case, it would not be a function. And the main reason for that is because as we draw that line through two of our points, they do come up with the same value. So 1x is providing 2 y's, which means this would be a function. Let's go ahead and take a look at our next problem. Correction, this would not be a function. Let's take a look at our second problem. For this graph, we have a pentagon that's being given. So, as we take a look at our x values, keep in mind we are going from furthest left to furthest right, and we know that because, notice we have straight lines, solid straight lines, going from the furthest left to furthest right point. So this would be from -3 to a +3, and our range would actually go from -4 to a +3. Sometimes labeling it out as such would make life a little bit easier to be able to provide those answers. Let's start off with our domain. Our domain in interval notation would be from -3 to +3. In set notation, x such that x, or technically x such that -3 is less than or equal to x, which is less than or equal to 3. For our range in interval notation, this would go from -4 to +3. In set notation, this would be y such that y would be equal to all numbers between -4 and 3. So we could write it as y such that -4 is less than or equal to y, which is less than or equal to 3. And we close off our bracket. In this case, when asked if it would be a function or not, this would not be a function. As you run your vertical line test, this line would go through both the top parts and the bottom parts of this graph, which would not be a function. Our last example for this slide, our domain would be from -4. Now keep in mind, the -4 itself would not be included because we have an open circle, and it would continue to go towards a positive infinity. So in our domain, in interval notation, we would go ahead and write it from -4 to infinity. And in our set notation, we would write it as x such that x is greater than -4. In the case of the range, we have our lowest number being 1. And yes, we do go upwards, and we have to keep in mind that we have an open circle here. But because this line continues to travel up in that direction, it will also pass through the 3. So we would be able to say that we are going from -1 to a positive infinity. from 1 to positive infinity. So range and interval notation would be from 1 to positive infinity. Your 1 will have a bracket, and your parentheses would be wrapped around the infinity. In set notation, we would have y such that y is greater than or equal to one. So in this example, notice because we are working with range, we do have a greater than or equal to sign because we have 2 points on that 1 and we have a solid line. When asked if this would be a function, yes, this would be a function. It would pass the vertical line test. Let's go ahead, take a look at slide 17. There will be times where we are going to go ahead and write it in set notations and interval notations. It is extremely important that you are familiar with both, which is the main reason why these different slides continue to ask you multiple times to write it in both, is to practice in both forms. So in this first problem, we can easily see that this is not going to be a function. We go ahead, take care of our domain. So in interval notation, it is going to go from -2 to a +2. And we would have brackets around it. In set notation, we would write this as x such that -2 is less than or equal to x, which is less than or equal to +2. For our range, in interval notation, keep in mind we are going from 0 up to 4. So 0 and 4. Since we have a solid line, there would be brackets on both sides. In set notation, this would be y such that 0 is less than or equal, let me write that clear, is less than or equal to y, which is less than or equal to 4. In our next problem, once we do our vertical line test, in this case this would be a function. We can easily see that our domain in this case, in interval notation, would go from -infinity to +infinity. Our set notation would be x such that x equals all real numbers. Our range, interval notation, once again would be -infinity to +infinity. And our set notation would be y such that y is equal to all real numbers. As we are taking a look at our third example, this would be a function and would pass the vertical line test. Our domain does go into -infinity and +infinity. Our set notation would be x such that x is equal to all real numbers. Our range in this case, notice we have a lowest number. This would be -5, and it continues to go upward towards positive infinity. So our range in this case for interval notation would be from -5, which would have a bracket, to positive infinity. Our set notation would be y such that -5 is less than or equal to y, which is less than positive infinity. Now this is extremely important to pay attention to, because notice, because we have a bracket on the -5, and because we have a solid point there, we are doing the less than or equal to sign on the -5, but we are using a less than sign for the infinity because we are dealing with infinity. Let's go ahead and take a look at slide 18. So, as we go ahead and run through these problems, we go ahead and take a look at the domain. In the case of the domain, we can easily see that we have two specific numbers, and that is at -3 and at 2. So for the domain and interval notation, we would have bracket -3 in union with bracket 2. Our set notation would be x such that x is equal to -3 and 2. In the case for range, interval notation, we are taking a look at our y values. Keep in mind, it is going from -infinity. We are going up, and because we are hitting solid dots here, it is still including the 2 value all the way up to a positive infinity. So interval notation would be -infinity to positive infinity. Set notation would be y such that y is equal to all real numbers. We go ahead and take a look at our next problem. Now, as far as our domain and interval notation, keeping in mind that as we run from left to right, we do not cross over itself multiple times. This would be from -infinity to positive infinity. And set notation, x such that, correction, actually, not -infinity. This would be from -5 with a parentheses up to 5 with a bracket. It's extremely important to notice that there's a closed circle and an open circle. It is very easy to just kind of skip over those. Make sure that you're going ahead and writing out those parentheses, those brackets wherever needed. For set notation, we would go from -5 is less than x, which is less than or equal to 5. In the case for our range is going to go from -2 all the way up to a positive 2. So in interval notation, this would be a bracket -2 to a bracket positive 2. Set notation would be y such that -2 is less than or equal to y, which is less than or equal to 2. We're going to go ahead and we're going to take a look at our domain for our next problem. Our domain for our next problem in interval notation, keep in mind we go from left to right. There are arrows on both ends, which means we are going from negative infinity to positive infinity. Our set notation would be x such that x is equal to all real numbers. Our range, in the other hand, interval notation, set notation. Interval notation is going from negative infinity to positive infinity. Although it does kind of loop back towards the bottom and then comes back up again, in this case, that range will still not be affected. In set notation, we would have y such that y is equal to all real numbers. Let's go ahead and take a look at slide 19. In this case, for our domain, we are going for the interval and set notation. This would be from negative infinity to positive infinity. Our set notation would be that x such that x is equal to all real numbers. When taking a look at the range in interval notation, keep in mind because it's a horizontal line, the range stays the same, which means this would be a bracket of 3, and that would be our answer. In set notation, we would have y such that y is equal to 3. In this case, this would be a function, considering how it does pass the vertical line test. Let's take a look at our next problem. In this case, our domain in interval notation, since that line continues to push towards the left and the right, this would go from negative infinity to positive infinity. Our set notation would be x such that x is equal to all real numbers. In the case of our range in interval notation, keep in mind we are starting at 0 and we are going towards positive infinity. So we would have a bracket 0 to positive infinity with a closed parentheses. Our set notation would be y such that 0 is less than or equal to y, which is less than infinity. Close that off. We could also write this as y such that y is greater than or equal to 0. Either one of those answers would work for that problem. For example, number 3, the domain in interval notation would go from negative infinity up to 4, and we would put a bracket around it since there is a solid dot on the 4. Set notation would be x such that x is less than or equal to 4. In the case of range, our lowest number would be 0, and we are going up towards positive infinity. which means the range in interval notation would be a bracket 0 to positive infinity, and set notation would be y such that y is greater than or equal to 0. Our last example would be the domain in interval notation. Keep in mind from left to right, furthest left is -4. Greatest number would go up to the number 3. Keep in mind we would not include the 3 because there's an open circle, which means we would write this as a bracket of -4 going up to 3 with a closed parentheses, and our set notation would be x such that -4 is less than or equal to x, which is less than 3. Keep in mind we have to make sure that we put less than 3 because we do have an open circle on the 3. You might be asking, well, what happens with the 2 since we have an open circle on the 2? Keep in mind the line on this side went through the 2, which means we did include that 2. The range on the other side, in interval notation, keep in mind we are starting off at -5 and we are going up to the +5. This is an open circle. This is a closed circle, which means that as we are writing the interval notation, we would write it as a parentheses of -5 up to 5 with a bracket. Our set notation would be y such that it would go from -5, and we would say that it is less than that -5 to y less than or equal to +5. Close that off with a bracket. Keep in mind, this would be not a function. This would be a function. This would be a function. And our first example would also be a function. If you have any questions on any of one of these questions, please feel free to ask at any point.